Hi all, welcome to ugcnet. This video will be going through the analysis of a source program. That means how to analyze a source program. Here we can see that the analysis is done in 4 steps. That is, first step is a preprocessor, second is the compiler, third is the assembler, and fourth is the linker and loader. So this is the block diagram for the analysis of a source program. That is, the source program is first fed to a preprocessor. The preprocessor will modify the source program and the modified source program will be given to the compiler. The compiler will then convert this source program, that is, this modified source program will be compiled and it will be translated into some target language. The target program can be assembly program or it can be machine code. We have already seen what's a compiler and what all are the input and output of these compilers in my previous video. If you have not watched that video, please go and watch it and come back. Okay. So the second stage or the second step is the compiler. It will take the source program, that is a modified source program, as the input and it will produce a target code. The target code can be assembly or machine code. If it is an assembly code, then it requires an assembler to convert this assembly code to a relocatable machine code. Suppose that the compiler produces machine code as output. In that case, we don't require the use of assembler here. We can go straightly from the compiler to linker bar loader. But here, let's assume that our object code or the target code is an assembly language or an assembly program. Okay. So the compiler produces output an assembly program and we use an assembler to convert this assembly program to a relocatable machine code. And finally, a linker or loader will be used to translate this relocatable machine code into the original target machine code. And for this conversion, the linker will use some library files as well as relocatable object files. So let's see the details of each of these steps. The first step is preprocessor. The input to the preprocessor is our source program and the output will be the modified source program. So what actually we do is we are preparing the source program so that it can be compiled. And the main tasks that are done by a preprocessor are, the first one is file inclusion. File inclusion means that suppose in our program, in our source program, we have written the statement #include stdio.h. So what is this? This stdio.h is actually a header file, right? So this header file, this will be stored as a separate file, right? So what this preprocessor do is, it will include that file. Suppose this is our stdio.h, this is the stdio.h header file. The preprocessor will include this file into our program. Suppose we have 2 more header files, then the preprocessor will include those files also into our program. That is what we meant by file inclusion. Okay, so that is the first task of the preprocessor. And the second task is macros expansion. What is a macro? Sometimes you can see statement like this, #define pi 3.14159. Here, this means that we are defining the value 3.14159 as pi. So, in the program, wherever we want to use the value 3.14159, we can just use the term pi. Okay. So, this is what we call macros. So, the second task of preprocessor is macros expansion. That is, just imagine that I have used this term pi 10 times in my program. So, what the preprocessor do is, it will replace all the term pi with the value 3.14159. That is what meant by macros expansion. We are expanding the term pi with its actual value. So these are the 2 tasks of preprocessor. Remember, the first task is file inclusion and the second task is macros expansion. After including these files and expanding the macros, the modified source program will be obtained. Now this modified source program will be fed to a compiler. So the second step in the analysis of a source program is compiler. Now what the compiler do? That we have already seen in the previous video, right? The compiler will take the source program or the modified source program as input, and it will produce a target code. And the target code can be either an assembly language or a machine language. If it produces assembly code as output, then we need an assembler to convert this assembly code to the machine code. But if the compiler is producing the machine code directly, then we don't require the need of assembler. Okay. So here let's assume that the compiler is producing assembly code as output. And in most of the cases, the compiler will be producing assembly code only. The reason is that the assembly code is easier to produce rather than producing the machine code directly. Okay. Now the third step is that we will give this assembly code to the assembler, and the assembler will produce a relocatable machine code as output. So the third step is assembler. Here suppose that our source program, it was a very large program, and after pre-processing we obtained the modified source program, and for compilation what we will do is we will divide this large program into smaller programs or smaller modules, and then we will compile each of these modules separately. So here we will get some assembly code, here you will get another assembly code, here again you will get another assembly code, and this will be fed to an assembler, and these assemblers will produce relocatable machine code as output. Relocatable machine code 1, relocatable machine code 2, and relocatable machine code 3. Why the term relocatable? Because these machine codes can be relocated, or it can be transferred from one part of the memory to another part. That is why we call it relocatable machine code. So once we compile this large program in pieces, we will get multiple relocatable machine codes. So in order to create the target program, the first step is we have to link together all these relocatable codes. That is, we have to integrate these relocatable codes into a single code. This linking together of all these relocatable codes will be done by the linker. So it is the task of this linker to link together all these relocatable machine codes so as to obtain the final integrated target code. So the fourth step is linker, and this linker will perform this task with the help of some library files as well as relocatable object files. Now one more component that comes under the fourth step is loader. Now what is the task of this loader? The loader will load this target program to the memory. That is, this relocatable target program will be stored into the memory at its actual position so that we can execute or we can run this target program. So that is the task of the loader. Thus, only after loading is performed, we will be obtaining the equivalent target program of our source program. Or we can say, only after linking and loading takes place, we will get the equivalent machine code as output. So this is how we analyze a source program. So let's brief out. For analyzing a source program, it will be first fed to the preprocessor. Preprocessor will perform two tasks, that is file inclusion as well as macros expansion. After that, we will get the modified source program. This modified source program will be fed to the compiler, and the compiler will produce as output a target code, that is a target assembly program or a target machine code. If it is a target assembly program, then we need an assembler to convert it to the relocatable machine code. Suppose if the output of the compiler is the relocatable machine code, then we don't have to use this assembler here. So once we get this relocatable machine code, with the help of linker and loader, we will be producing the target machine code. The task of the linker is to link all the relocatable machine code into a single machine code, and the loader will load this integrated machine code back to the memory or into the actual position inside the memory so that we will be able to execute it. Thus, the final output obtained will be our target machine code. So that's all for now. Hope you all understood it very well, and I will be really happy to get feedback from you. So if you have any suggestions or any requests, you can comment it below. See you soon with another video of compiler design. Till then, bye.